So let me firstly discuss what is SVM and what is the task of the SVM. So it is it is the next classifier, and that is once again a supervised machine learning algorithm. That means what? Class column or labeled column is given, and it is classifier. Guys, SVM is used for classification as well as regression. दोनों के लिए use होता है. Okay, classification I mean to say you will have a categorized data in a class column or labeled column, and regression in the sense I mean to say there are some numerical values in actually class column or labeled column. Okay, so classification और regression दोनों के लिए SVM use होता है, so do not mind. But right now हम लोग classification learn कर रहे हैं, so like we just say SVM is one like it is another classifier. Okay, and guys, SVM को linear classifier भी बोला जाता है. So why SVM is known as linear classifier? Let me discuss something about that. And one more, like आज हम लोग सबसे पहली चीज तो डिस्कस करेंगे कि SVM का मेन यूज क्या है, क्यों SVM यूज करते हैं, because already we learned actually decision tree, KNN, naive Bayes, all three are the classifiers. Then why we have to learn the next one, that is SVM. Okay, so that is the fourth one. So the first question is what is the application of the SVM? जो हमारा एक्चुअल पैटर्न रहता है कि पहले हम लोग एप्लीकेशन डिस्कस करेंगे, दूसरे के साथ कंपैरिजन करेंगे, आफ्टर दैट उसका मैथमेटिकल फंडा समझेंगे कि बैकएंड में एसवीएम कैसे काम करता है. देन आफ्टर हम लोग दो प्रोग्राम करते हैं, एक तो पाइथन के थ्रू मतलब स्क्रैच, तो ऐसा नहीं करते हम लोग, बट कोई भी एल्गोरिथम को स्क्रैच से इंप्लीमेंट करते हैं. सेकंड थिंग इज हम लोग लाइक scikit-learn का यूज करके उसको इंप्लीमेंट करते हैं. सो लेट मी स्टार्ट. So what is SVM? It is also known as linear classifier, as I told you. Another thing is like already we learned decision tree. So decision tree में guys हम लोग को क्या learn करना होता है? So in decision tree we will have actually like consider I have 5 features. Otherwise हम लोगों ने जो example लिया था उसमें हम लोग like एक fraud detection कर रहे थे कि that particular taxpayer is actually a fraud or not. तो उसके लिए हमारे पास पहली चीज थी what is the marital status of that guy, what is the income of that guy, and etc thing. So actually जब आप decision tree पे काम करो तो हम लोग के condition put करते थे, according to that condition we can classify the data. So that condition will be actually a feature label. So we can say that like in decision tree we have to learn that particular tree model we have to learn. And that is actually known as parallel lines, axis parallel lines, that is actually known as, so that is decision axis or decision boundaries. So we have to learn decision boundaries in that. Okay, and as per the decision boundary, we can say the decision boundary in the sense I mean to say, like as per the features level, we can just draw a line, and we already draw this in some previous sessions. Like हमारे पास कोई feature के हिसाब से हम line draw करते थे. Okay, and according to that feature we can simply say that oh this guy is actually fraud or not. Okay, मतलब according to the decision boundary हम लोग उसको classify करते थे. So in decision tree अगर मैं broadly बोलूँ तो in decision tree we have to learn decision boundaries, we have to learn a decision boundaries we have to learn. Another one was KNN. So in KNN at the training time we didn't learn actually anything. Okay, at the training time हम लोगों ने actually देखे तो कुछ learn नहीं किया था. Okay, but in that KNN actually data is the model, and उसमें हम लोगों ने Voronoi diagram learn किया. So what is that Voronoi diagram? That Voronoi diagram is nothing but a decision boundary. So in KNN we have to learn a Voronoi diagram actually after the naive Bayes. So in naive Bayes, guys, decision boundary is a hard thing. Now what is the hard decision boundary and what is the soft decision boundary? So there are two types of decision boundaries, hard and soft. Hard in the sense what, like it's a strict one. Okay, it is a hard one. Hard one in the sense neither of the guy must be actually mixed up. And so let I say I have two class labels, class 1 and class 2. Class 1 and class 2. So like if I just draw a line between these two classes, then I am damn sure that class 1 will not be on other side of that particular line. In short, class 1 data will not be on class 2 side, and class 2 data will not be on class 1 side. So in naive Bayes we are actually storing the probabilities of someone, probabilities of features actually. So that's actually known as hard decision boundary, because internally we are using actually a probability in the sense Bayes in nature. Okay, so वहाँ पे actually Bayes theorem हम लोग in background use करते थे. So that is actually known as hard decision boundary. So these are the like decision boundaries or some algorithm revision, decision tree, KNN and naive Bayes. What about SVM? So SVM learns actually a single line only. So that's quite faster actually, guys. Okay, that is in SVM we have to learn a single line. So guys, अगर आप line का formula recall करें, So that is actually y equal to mx plus c. अगर आप line का formula एक बार recall करें, so that is actually y is equals to m x plus c. What is that m? That is nothing but a slope. What about that y and x? These are nothing but in coordinates. And what is that c? C is nothing but an arbitrary constant. So that is y equals to mx plus c. So that is nothing but a line formula. So in SVM, we have to just work on this formula. Otherwise, more general form of this formula is a1x, a1x1 plus a2x2 plus a3 equals to 0. That is also a line formula. Okay, that is also a line formula. So you can just guys use either of the formula. You can just use either of the formula. This is also the line formula. What is that? x1 and x2? These are nothing but in two coordinates. जहाँ पे मुझे line draw करनी थी. a1, a2 and a3 are nothing but in constants, or you can say that a1, a2 are nothing but in coefficients. a3 is a constant. Okay, so what is that? So we have to just go with this formula, and in SVM we have to draw a line to just differentiate a class. So consider you have two classes in your data set. So we have to draw a single line to just differentiate class A and class B. So that is an SVM. But guys, यहाँ मैंने सिर्फ दो class की बात की. If you have more than two classes, then guys you have to just draw a plane, or in short, a surface type of thing, a rectangle type of thing. If you have more than three, and then you have to just go with a hyperplane. Okay, so that we will learn in upcoming sessions. But right now the thing is, in SVM we have to just draw a line to just differentiate classes. That's it. So now where the SVM is actually used, so SVM is generally used in web document classification. That is the general thing. बाकी आप उसको image classification में भी use कर सकते हो. Digit classification as a digit class digit को भी classify करना है guys. You can just use SVM web documents को classify करना. You can use SVM face recognition के लिए आप SVM use कर सकते हो. It is a general classifier, and it was actually most usable classifier before a few years. Okay, after that some updated versions came, so abhi iska use kam ho raha hai, but it is also one of the most usable classifier. Okay, so I hope yahan tak clear hai. So now it is used in actually web document classification. So why we went to use it actually in a web document classification? Otherwise, what you want to do in web documents? So consider you have actually 5,000 websites, and you want to categorize these websites. Like some of the websites are for actual educational purpose, some of them from actual entertainment purpose. Some websites are for actually provide the details of news, some provides the details of politics, and some are from the actually finance domain, and etc. thing. So I have a bulk of websites. I want to classify this website in a given classification, in a given values. Okay. So guys, now consider now what is the fundamental things in websites. Okay, like what is the backbone, what we have to like focus on a website. So if we have a website, we have to focus on the words actually. So words are nothing but a features for that website. So we have to just fetch a word. You can say that we have a document in website. You have to fetch the document and extract the words from that document. So finally you will have some words from that particular website. On the base of these words, we have to classify this website is from class A, or this website is from class B, or domain A, domain B, and something like that. So as we know, there are large number of words. Okay, that is the first thing in a web document. There are large number of words. Another thing is, let I say I have 100 websites, and throughout these 100 websites, we have actually 1 lakh words, 1 lakh unique words actually. Now, it is not possible that 1 lakh unique words available in all these websites. That is not possible. So consider in each and every website, we have some 10,000 common words. In short, 1,000 words is nothing but in vocabulary. Now, from that group of words, a set of words, a population of words, in a first website, only 10,000 words occurs. Only 10,000 words exist actually. So what we have to do, we learn in Neubas, what we have to do in a text classification, we have to just create a matrix that is actually classification matrix. And what we have to do in that classification matrix, all the words will become a features. In short, all the words will become a class, all the words will become actually columns, and the particular website will become a row, in short, document. So what we have to do, we have to just write down a frequency. We have to count a frequency of a particular word in a particular website. and in that matrix we have to just mention a frequency actually. So that will be a sparse matrix. I hope guys this is clear. So let I once again let I just draw that. So consider this is a table, that is actually table, and inside that table this is the column for word 1, this is the column for word 2 and onwards. So here we have actually total like 10 lakh words or 1 lakh words. Now consider this is my first document, in short first website. Now this word 1 appear for 5 times actually. Now this word 2 doesn't exist in actually my website. In my website this word does not exist, so we have to put zeros. So in that actually consider we have actually 10,000 words. Let I say we have actually 10k words. Okay, and in my website only 100 word appears. So what about the remaining columns? So in remaining column we will put 0. So guys, you know what is the definition of the sparse matrix? If you have maximum number of zeros in your matrix, that is actually known as sparse matrix. So after this we will have actually a sparse matrix. Okay, so what we are just discussing, the thing is where the actually general, what is the general use of actually our SVM. So it is generally used for web document classification. In web documents, generally there are large number of words, large number of features, and generally consider we have 10 records or 10 websites we have. We have large number of columns, but only 10 websites we have. Okay, so relatively low number of labeled training sample very available. That means what? Like we have 10 labels, or we have actually only 10 websites for the classification. तो ट्रेनिंग डेटा गाइज हमारे पास बहुत कम है, बट ट्रेनिंग डेटा में कोई भी एक पर्टिकुलर आप ट्रेनिंग रिकॉर्ड ले लीजिए, उसमें कॉलम्स बहुत ज्यादा है. So that is the situation in website. Consider you have only 50 websites. You want to classify 50 websites, but you have 1 lakh words, 1 lakh unique words. So there are lots of columns, but some records are there. So after that, sparsity will be there, highly sparse data, because हम लोग उसके लिए actually classification matrix develop करेंगे, and in that matrix, lots of zeros will be there. Okay, so now guys, in such cases, guys, we can just use a decision tree, not the actual decision tree, but boosted decision tree. That is the updated version of decision tree. We will discuss that also in upcoming session. But now that is not a good idea if you have more than 4k features. If you want to apply boosted decision tree, then it's fine. But if you have more than 4k features, then boosted decision tree is not actually an accurate one. Okay, uska like accuracy level काफी decrease हो जाएगा. So what to do? So finally we have SVM. So what is the actual use of the SVM? Otherwise, where we have to use the SVM? What is the actual purpose? Not only actually web document, but what is the actual property? Otherwise, in which area the SVM is used? So if you have large number of properties, if you have a like sparse type of data, if you have a sparse data, and if you have low training data, guys, please go with the SVM. So it is known to perform very well, even with very low training data. Training scales will be large, well, with a large number of features. So guys, mainly 2 properties, actually 3 properties. अगर आपके पास sparse data, you have to go with the SVM. You have large number of columns in your data set, go with the SVM. If you have actually low training set, please go with the SVM. Okay, now it's not mean कि SVM large data set के साथ work नहीं करता. It is accurate with the large data set also. Okay, that is the one of the most popular actually algorithm. So I hope you guys just got the idea where we have to use the SVM actually. So now let me just start. So before starting the SVM, let me just discuss the linear classifier, because SVM is also known as linear classifier. As we discussed, SVM is also known as the linear classifier actually. So SVM is a linear classifier, but what is the meaning of linear classifier? Once you get the idea about the linear classifier, almost the SVM concept is over. So let me just discuss a linear classifier. What is linear classifier? So now guys, actually as we discussed, SVM is a classifier. That means what? That means it is just used to classify the inputted data into some category. Let I say I have one data. Let I say I have actually 10 records, and I want to classify the 10 records in 2 categories. Either of the data will be of first category, or this data will be of actually second category. So I want to classify them. Okay, so what is the meaning of classifier? You know, guys, but what do you mean by linear classifier? Linear classifier in the sense what? I want to just draw a line in between a set of data. I want to just draw a line in between a set of data. Just consider I have 2 things like this is not a clear image actually. Here these are nothing but an actually round like dots, and these are nothing but in cross. Okay, so we have two different categorized data as per the training data set. मेरे पास दो category के data है, either round or cross. Okay, and in between that I want to just draw a line. मैं आपको पहले basic idea दे देता हूँ. In between those data I want to draw a line. So that line is nothing but a linear classifier. That line is nothing but a SVM. So now whenever the testing data or query point comes, what is my requirement? My requirement is as per that line is nothing but my model. As per that line, I want to just classify, should I put that training or sorry, should I put that testing point or query point above the line or below the line? That is the classification. That is quite simple. So what is my requirement? In linear classification, or in SVM, I want to just draw a line. Right now, हम लोग सिर्फ linear classification की बात कर रहे हैं. We are not talking about the non-linear. What is the difference between linear and non-linear? Linear and non-linear in the sense either of the data, जो भी मेरे पास एक्चुअली यहाँ पे दो कैटेगरी के डेटा थे, राउंड एंड क्रॉस, वो एक दूसरे में मिक्सअप नहीं है. ओके, मैं इनको सिंपली दो पार्ट में लीनियरली डिवाइड कर पा रहा हूँ. दैट इज लीनियर क्लासिफिकेशन. इन अपकमिंग सेशन आइदर इन द नेक्स्ट और नेक्स्ट टू नेक्स्ट सेशन हम लोग नॉन लीनियर क्लासिफिकेशन भी डिस्कस करेंगे. मतलब नॉन लीनियर डेटा को भी एसवीएम के साथ डिस्कस करने वाला है. Okay, so right now up to this session, let me just discuss the linear classifier. So what is linear classifier? It is just used to divide your data into two parts. Right now, let me just discuss two parts only, but maybe it will be a 3-part, maybe it will be a 4 parts. In short, it depends on a class label or class values, different class values. So now in this case, let me just discuss our classifier will divide our data set into 2 parts only. The first one is actually like cross labels, another one is actually round labels. What is the D, what is the W? Just ignore that. So हमारे पास दो चीज है. Now what is our next target? Our next target is whenever the new test point or query point comes in, I want to just say, okay, that is from actually cross label, or that is actually from actually round label. So मुझे सिर्फ classify करना था. So this line is nothing but our model. So now how to draw this line? So guys, as we know, this is the equation of line, y equal to mx plus c. And that is actually equation with actually slope. But guys, you can just write out this equation in this way. So ax plus by plus c equals to 0, or you can say that w1 x1 plus w2 x2 plus w3 is equals to 0. What is the w1 and w2? Are nothing but in coefficient of x1 and x2. And what about that w3? W3 is in constant. Now guys, plus c or plus w3, it doesn't matter. It is a constant, so minus भी ले सकते, plus भी ले सकते हो. So in future, like you can just change the sign of that particular constant. In some slides I just use minus, in some slide I just use plus to inform that doesn't matter, the sign doesn't matter with the particular constant. Okay, the constant की sign के ऊपर focus नहीं करेंगे. We have to focus on x and we have to focus on w. Now what is the w? That is nothing but a weighted vector. What about that x? These are nothing but in features. So whenever your new record comes in, this is actually a line. This is actually a line formula. But let I just say, after this line, we will conclude a formula. From this line formula, we will conclude a formula for SVM, and in that formula, x will be a feature. Right now, right now here the x1 and x2 are nothing but in coordinate values for a particular line only. But in future, जब हम SVM की बात करेंगे, तो x1, x2, these are nothing but in features. What about W1 and W2? This is nothing but a weighted vector. What is that weighted vector? What about the W3? We will just discuss in a few minutes. Okay, so that is nothing but a line formula. Why we are discussing the line formula? Because we want a line in between our data set. We want to draw a line, so for that we have to discuss the line formula. So this is the general formula. Now for the three dimension, guys, your line formula will be W1 x1 and plus w2 x2 plus w3 x3 plus w4 equals to 0. So now let I just simplify this formula. Okay, I do not want to write down from w1 x1 to w3 x3. Let I just write down, it's nothing but a multiplication of wi and xi. It's nothing but a multiplication of wi and xi, and finally that's nothing but a summation of this multiplication. So simply I just write down sigma of I equals to 1 to 3, because I'm working in a 3 dimension. Wi xi plus w4 equals to 0. But now if you have n dimensional data, then guys, that is actually w1 to that's actually I equals to 1 to n, I equals to 1 to n and wi xi and wn plus 1 y n plus 1. अगर 3 डायमेंशन था तो मैं यहाँ पे 4 लिख रहा था, जस्ट चेक. अगर 2 डायमेंशन है तो हम लोग यहाँ कांस्टेंट की वैल्यू w3 लिख रहे थे. Now it's a like little bit of confusing thing, so let I just cut this wn plus 1. In the place of that, let I just use another constant that's nothing but a b. Okay, let me just use some another thing that is nothing but a b. So let I just say now for the n dimension, the equation, the linear line equation will be w sigma actually I equals to 1 to n wi xi plus b equals to 0. Now guys, now in line in 3 dimension is plane. In short, in 2 dimension we have to just draw a line. So this is the line which we have to draw to separate our data set. That is nothing but a line actually, to just categorize or to differentiate the category. That's nothing but a line. But if you have actually 3 dimension, if you have 3 different category of data, this line will become actually a plane as per our data. And if you are working with the n dimension, that is actually known as hyperplane. Okay, just ignore that. Like these are nothing but in terminologies. What is plane? What is actually hyperplane? So like hyperplane, it's not a plane, it is plane. Okay, that is not a plane. So what about hyperplane? Hyperplane actually, that is actually in multi-dimensional. Let I say n-dimensional. The separator is actually known as hyperplane. We will discuss this terminology in upcoming session. Just ignore that. That is for knowledge only. So now, guys, this is my general formula. Let I just cut all this. This is the general formula. Okay, this is the general formula for actually SVM, or you can say that for not actually SVM. That is a general formula for actually to draw a line to separate the category. Now, in the place of this sigma I equals to 1 to n wi xi, let I just simplify that to this one. So what is the formula in Angular? Just I write down w comma x. That is also the notation to write down sigma of I equals to 1 to n multiplication of wi to xi. So that is also known as multiplication of wi xi, and this angular bracket say, oh, that's nothing but a summation of multiplication for whatever the features you have. What about this plus b? That was actually in the place of wn plus 1. I just use a b to remove the confusion, because w is nothing but a for weighted vector. W is for the weighted vector, and what about this b? It's a constant. Okay, so many different notations used here. That's that. And now here I just explain what about x bar and z bar. That's actually here I just use z, because in some websites you will just get the idea, oh, that's actually z. In some websites you will get, oh, there is a w. So both having the same meaning. In some websites you will just get x bar. So it doesn't matter. But in angular bracket, if you guys just write down x comma z or z comma x, that's nothing but a multiplication. And in multiplication, association rule is there. That means a into b is equals to b into a. So what is the meaning of this angular bracket? In the bracket a comma b, that means sigma of I equals to 1 to n ai into bi. Ai into bi in the sense I mean to say here I have w and x. So meaning of that is multiplication of w and x, where and sigma of sigma will start from 1 to n. So yeah, if you have 3 dimension, then w1 x1 plus w2 x2 plus w3 x3. And in a similar way, this is also the same notation actually. Okay, this is also the same notation. So either of the notation, guys, you can just use to just represent the linear classifier. Okay, what is that linear classifier? That linear classifier is nothing but just used to classify, otherwise just used to differentiate your data set. So whenever the training data set comes in, I want to just divide my training data set as per actually 2 class labels or as per 2 categories. Then just draw a line. But if you have 3 class labels, just go with the 3D plane. If you have an n class labels, then guys, just you have to go with the hyperplane. So still we will discuss for actually only a line, because firstly we will just try to learn how to draw a line, then we will just learn how to draw a plane, then we will learn how to draw a hyperplane. Okay, so fine. So this is nothing but a general equations to draw a line. So what is that line? As we just discussed in the first slide, in SVM, we have to just draw a line. We have to learn a single line only. We have to just learn a line, nothing else. So what is the line formula? That will be the formula for SVM. Okay, so this is the general formula for SVM. We will discuss we will discuss some more things on this formula in later sessions. But the guys, this formula we will use actually. Not for SVM, we will just modify a little bit, but this is the basic formula for the SVM. What about the w comma x? The w will be a weighted vector, the x will be actually like feature values, and angular bracket in the sense what? This is nothing but a summation from I equals to 1 to n wixi plus b is nothing but a constant. So guys, you can just use plus b or minus b. Okay, in some slides I just use a minus b. So now let me just say, now let me just take an example of this like linear classifier. Here I have a binary classification. Okay, here I just choose the binary classification problem. That means I have only two class labels. Let I say red browns and the blue dots, red dots and blue dots. These are nothing but in classifications. These are nothing but in class labels. So now when the training point comes in, I have to say, oh, this is this according to the feature values. I can say, oh, this is nothing but from actually red label. Otherwise, I can say that, oh, that's from the actually blue circles. Okay, so guys, I want to just predict something. Either your query point is from a red or blue label. So now, what is our first task? At the training time, we have to draw a line to just differentiate these two class. So how to draw a line? So simple. This is the way to draw a line. Okay, but as we know, there are lots of ways to draw a line, guys. Like we can just draw a line in this. Oh, just a moment. So here we can just draw a line in this way or this way or this way. There are lots of ways to draw a line. Okay, there are lots of ways to draw a line. So let me just discuss this one in step by step. Okay, so this is the line. This is the line. This line we have to learn. And what was the formula for this line? That formula is actually wx plus b equals to 0. I just use a transpose. We will discuss that also in later, but that will be the equation. This equation we derived from the previous session, from the previous slide. That is actually wx plus b. Okay, so what is the wx plus b? Whatever the number of x and whatever the number of w you have to just multiply them, sum them, and plus b is equals to 0. This is the equation to draw the line. Okay, now what about w and t? These are nothing but in vectors. Okay, w and t are nothing but in vector in the sense it's a one-dimensional array. Okay, w is in weighted vectors and x is nothing but a feature vector, as we discussed. So now after that line, after we got the line equation, what is our next task? Whenever the query point comes in, we have to just apply this formula wtx plus b, and we have to, now this guys, just focus on this. This line have the line this formula having 0 on right hand side. That means what? We have to choose the line. We have to just choose the line where we have to just choose the value of w and b. Why I'm just telling we have to choose the value of w and b, because x is given. X is nothing but a feature value. X is nothing but a feature value. So we have to choose the value of w and b so that the right hand side must be satisfied. In short, equal to 0 hona chahiye. So we have to choose the value of w and b. Now after just generating the equation, after drawing that line, what is our next task? Whenever the query point comes in, we have to apply for that query point. We have to just fetch the feature value. We have to put the value of w. We have to put the value of b. जो हमने actually learn किया था, वो values w और b की हम use करेंगे. Query point के features in the sense x को हम लोग use करेंगे, and we will just compute the answer. If the answer is greater than 0, if the answer is greater than 0, like we will say, oh, that is for this query point, the answer is red point. If the answer is less than 0, we can simply say that for this query point, the answer is actually a blue point. Okay, so above the line and below the line. So that's pretty simple. First of all, we have to generate the equation, and as per the training data, we have to just calculate the w, and we have to guys just calculate the b. And finally, we have to for the query point, this will be the function. For the query point, this will be the function. In short, we have to just put the value of w. We have to put the value of b. From where we have to get the value of w and b? From the training data. Okay, so हम लोग को यहाँ पे learn क्या करना है? We have to learn actually the value of w and b. And what about this x? X is nothing but a feature value. तो जब आपका query point और testing point appear हो रहा है, तो उस query point और testing point में जितने भी feature value है, that will be the value of x. इन सब का like multiplication, summation सब कुछ find out करें, equation को solve करें, and you will get the answer. Answer doesn't matter. The sign is matter. Okay, if you are working in a if you are working with the binary classifier, the only sign is matter. If sign is positive, you can say that, oh, that is from class A. If sign is negative, you can say, oh, that is this data having a label class B. Okay, fine. So like what we have to learn, we and decision tree, what we learn. So in decision tree, we learn some rules, decisions, some rules in the sense, some conditions we learn. Okay, in the decision we learn, decision tree we learn. What about KNN at the training time? In KNN, we didn't learn anything because your data is actually a model. What about neighbors? Various probabilities we learn, we compute various probabilities and we store the probability as a model. But what about in SVM? In SVM, guys, as per this formula, we have to learn only two things, W and B. But now, as we know, like sir, there are so many lines we can just draw. We can just draw so many lines to separate these two class labels, or as to categorize binary classifier data. There are lots of lines are possible. So which and from each and every line, I can just compute a value of W and B. So in short, we will have actually lots of values or multiple values for W and multiple values for B. So which one is the best? So guys, you have to choose the best one from the at the training time. So what we have to discuss in SVM, we have to discuss how to compute W, how to compute B, and from multiple values of W and B, which are the best value of W and the best value for B. And after just choosing the best value, we have to use these values and X in the sense that's the feature value of the testing data of the query point, we can just predict the outcome. So that's as pretty as simple. Okay, so now what is the next thing? SVM procedure. So what we have to do, we have to firstly calculate in a training part. That's guys, it is similar to other classifier. In short, we have only 2 points, training and testing. So in training part, we have to just find out the best value of W and B. Okay, and in a testing part, we have to just use this W and B and the X in the sense of feature value to just predict the class label of that particular testing point. So now this thing we have to learn. So this is the thing what we have to learn. Okay, so now at the training part, we have to learn W and B. Now we have to just use this function. What is that function? This function is nothing but actually in this function there are three arguments: X in the sense the feature values, and W and B what we learn at the training time. And finally, what about this function? This function is actually a sign of WX plus B. Let's just focus on this. I just use a minus, and after that I just update that. So guys, this is the constant value. You can use minus as well as you can just use plus. That's not a big deal. Okay, so just ignore that. So now what is the function value? That's actually sign of Wx plus B. Just put the value of X, put the value of W, put the value of B. You will get the sign, and as per the sign, as per the positive or negative sign, we can just predict like for this particular input, this will be the Y value. This will be the prediction value. So that's nothing but in working of the SVM. So now here I just say, okay, now black dots are denotes positive, and that's actually filled dots denotes positive, and actually unfilled dots denotes a negative value. Okay, so I want to just draw a line. So now the first question is, how would you classify this data? Okay, this is the data. How would you classify the data? So we have to just draw a line. So there are more than one possible lines. Okay, so from each and every line, guys, we will get a value of W and B. But there are lots of lines. There are lots of possible lines. So how to choose which one is the best one? Okay, any of this would be fine. अपने पास 3 लाइन थे, तो इसमें से कौन सा अच्छा है? And which one is the best? So how to calculate the best one? So first thing is, in SVM, what we start at the beginning point, what we learn in SVM, we learn one thing. If you have a binary classification, then we have to just draw a line. If you have a 3D plan, then if you have a 3 classifiers, then we have to draw a plane. If you have n things, then we have to just draw an hyperplane. But right now, हम binary classification के साथ work करेंगे. Then in SVM, we have to just draw a line, and that line will be a model. Okay, that line will be a model, and as per that line, guys, we can just classify our outcome. But now the thing is, how to draw a line, and what we will conclude from that line. So एक बार अपनी line draw किया, and line draw करने के बाद हमको सिर्फ 2 value की जरूरत है. We want to just store W, and we want to just store a B. And as per the W and B, and as per the feature value of that, feature value is nothing but X of the query point or testing point. We can just compute. We can just find the sign of that answered value. Okay, if that is positive or if it is negative, then we can simply classify on the base of that sign. Okay, output label we can just classify as per on the base of that particular sign. So that's the thing. But now the problem is we can just draw multiple lines to just differentiate or to classify this data. And this multiple lines, we will have actually multiple values for W and multiple values for like B. And how to solve this? How to choose the best one? So now for that, let me just take a simple example. So now consider this is the line. Now consider this is the line. Otherwise, let me just take an example firstly. Okay, so that's actually a non-technical example, but consider this is these guys are actually like black monsters, and this guy are actually white monsters. Okay, and you are at something over here. You are at something over here, and you want to cross this desert, or you want to just draw a path in between this white and black monsters, and you want to reach over here. So what you will do, guys? Consider, make them simple. For example, there are okay, now there are some guys on like on actually like with actually black symbol, and there's guys with actually white symbols. Okay, और ये सभी guys हम लोग को actually harm कर सकते हैं. In short, they are harmful guys, and we want to just move from x1 to x2. That's mandatory. हम लोग को यहाँ से यहाँ तक move करना है. ओके, और दोनों साइड पे माइंस लगे हुए. कंसिडर दोनों साइड पे माइंस लगे हुए, बट मुझे x1 टू x2 पॉइंट पे जाना है. ओके, सो कैसे आप पहुंचोगे गाइस? लाइक आप कौन सा पाथ चूज करोगे? किस तरीके से पाथ चूज करोगे? यस एनीवन? मौलिक सर, विजय सर, पृथ्वीश, आप किस तरीके से पाथ लोगे? ओके, नाउ वन थिंग प्लीज केयरफुल, वो लाइन जो मैंने जो बीच में लाइन ड्रॉ की है उसमें थोड़ा कर्व शेप है. दैट इज नॉट द कर्व्ड शेप. ओके, लाइन कंपल्सरी स्ट्रेट होनी चाहिए. ओके, बिकॉज वी आर जस्ट ड्रॉइंग अ लाइन. तो किस तरीके से गाइस आप लोग डिस्कस मतलब लाइन चूज करोगे? देयर आर मल्टीपल वेज एज वी डिस्कस, देयर आर मल्टीपल वेज. सो ये मल्टीपल लाइंस में से आप कौन सा चूज करोगे? यस मौलिक सर.
सर ब्लैक और वाइट में दोनों में एग्जैक्टली जो सेंटर में पड़ता होगा ना.
एग्जैक्टली सेंटर. दैट मीन्स सर ने ऐसा बोला कि ओके मैं एक काम करूंगा कि अगर दोनों साइड मॉन्स्टर्स है ओके तो मैं हो सके उतना मैक्सिमम डिस्टेंस रख के चलूंगा. मुझे ना तो ब्लैक वाले
यस
के
सर.
नजदीक जाना है, ना तो मुझे व्हाइट वाले के नजदीक जाना है. दैट मीन्स मैं मैक्सिमम मार्जिन वाली लाइन ड्रॉ करूंगा. रीजन इज guys यहाँ in short that is the answer like what will be the best value for the line, what will be the best value for W, what will be the best value for B. So what we have to do, we have to choose a line with the maximum margin. So in upcoming session we will just discuss how to calculate a maximum margin, how to calculate the margin firstly. Okay, and from the bulk of margins we will choose a margin with the maximum value. But the thing is why we have to do this, because well, that was actually a non-technical example, but why we have to choose the maximum margin line? The reason is training data having not all the data. In short, consider we have 1000 training records, but हो सकता है कि जब टेस्टिंग पॉइंट अपीयर हो तो टेस्टिंग पॉइंट ट्रेनिंग डेटा में अवेलेबल ना हो. और ऐसा होता ही है कि आपने जो भी चीज ट्रेनिंग डेटा के लिए यूज किया हुआ है वो सेम वैल्यू आपको टेस्टिंग में नहीं मिलती. So we cannot say कि training data are enough to classify my data or to generate the classifier. Training data are not enough to generate the classifier. हो सकता है कि जब टेस्टिंग पॉइंट आए, मान लो मेरे पास, let me just remove this manually drawn line. Okay, now consider हम लोगों ने ये लाइन चूज किया. Okay, अब आपका टेस्टिंग पॉइंट अपीयर हुआ. अदरवाइज लेट आई से मैंने ओके लेट आई जस्ट चूज दिस लाइन. अदरवाइज लेट आई चूज दिस लाइन. हम लोगों ने ये कुछ लाइन ड्रॉ चूज किया. नाउ जब आपका टेस्टिंग पॉइंट अपीयर हुआ एंड एज पर द एक्चुअल डेटा, एज पर द एक्चुअल लेबल, द पॉइंट इज ब्लैक, बट हो सकता है कि वो पॉइंट इसके इस तरफ पहुंच जाए. ओके, ये जो लाइन हमने सेकंड वाला लाइन लिखा था उसके राइट हैंड साइड में वो पॉइंट पहुंच गया एज पर द फीचर्ड वैल्यू. ओके, एज पर द वैल्यू ऑफ W एंड B एंड X, वो लाइन वो प्रेडिक्शन हुआ व्हाइट लेबल. सो दैट वाज द रॉन्ग थिंग. एक्चुअल डेटा ऐसा नहीं बोल रहा था. ओके, अदरवाइज एक्चुअल लेबल इस तरीके से नहीं था. अगर मान लो हम लोगों ने ये लाइन चूज किया और आपके पास कोई व्हाइट पॉइंट था जो यहाँ पे गया. ओके, तो हो सकता है कि आप अगर नियरेस्ट कोई भी एक कैटेगरी के नियरेस्ट हो तो उसके कोई पॉइंट आपके लाइन के अपोजिट डायरेक्शन में प्रेडिक्शन प्रोवाइड करें. तो दैट वाज दैट पर्टिकुलर, अगर आपने कोई रॉन्ग लाइन चूज कर दी तो गाइस आपका एक्यूरेसी लेवल डाउन हो जाएगा. तो दैट वाज द प्रॉब्लम. So what we have to do, we have to choose the best one. And what is the rule for the best one? We have to choose a line with the maximum margin. We have to choose the line with the maximum margin. So that's the solution how to choose the best one. So for that we have to choose the line with the max margin. So in short we have to draw a road. Okay, हम लोग को एक रोड ड्रॉ करना पड़ेगा और इन बिटवीन दैट रोड हम लोग सेंटर से चलेंगे. So what is that road? We will just that is nothing but in concept of margin of SVM. Okay, road तो नहीं बोलेंगे guys हम लोग, but that is actually a margin of SVM.